Hey guys, welcome to another video. Today's learning objective is to understand and use standard mathematical formulae and rearrange formulae to change the subject. In terms of prerequisite knowledge, just make sure you check out the last video, lesson 25, on how to what formulae are basically, just to have a quick definition. As usual, feel free to skip to any part of the video thanks to the timestamps here. Okay, let's get into it. Definitions, I covered what formulae were in the last video, but basically just an equation that describes the relationship between certain variables. So say speed equals distance over time. There's some standard mathematical ones which are that you need to know for your GCSE, and sometimes in the formula booklet it might not actually tell you what each of the letters stands for. So it's important to know these and be able to use them beforehand. I'll go through an example of one, but I've included a list of the ones you need to know in the description of the video. So one of the examples is, say, the area of a circle, and the area of the circle A equals pi r squared. And a lot of the time we'll just have these letters instead of it saying area equals to pi times radius squared. So you need to know sometimes what these letters stand for. So say, for example, I was given the radius, and the radius equals 5, and I'm asked to calculate what the area is. So all I do is area is equal to, so basically just substitute this value in to the equation, pi times by 5 squared, which is 25 pi. Now, depending on the question, sometimes I can leave this in exactly as 25 pi, or sometimes perhaps I might need to get out my calculator and give it to, say, 3 decimal places. It should specify in the question. So knowing this, we do this, and it's basically that. Perhaps they might give you the area and say the area they tell you equals, I don't know, say 49 pi. In that case, what you need to do is rearrange the equation and solve it, which I'll show you how to do, for example. So you have to rearrange this equation in terms of this equation, so we have it in the form of r equals something. Let me just talk you through how to do that, and then we'll move on to the worked examples that I have ready. So to rearrange this, what we have to do is basically isolate the r. We have to get the r on its own on the right hand side. So we have to get rid of everything that's associated with r. So we have a equals pi r squared. So if you want to get rid of everything associated with the r, what we first do is we can divide through by pi, divide both sides by pi. So if we divide the left hand side by pi, we have a divided by pi, and we have the right hand side, pi r squared divided by pi, which just gets rid of this pi, which is what we wanted to do. So we have r squared is equal to a over pi. I moved the r squared to the left just because that's how we usually have it. We usually have the thing that we want the equation to be rearranged in on the left. So how we have a here, we'd want, say, if you want to rearrange it so it's r is the subject, we have it on the left. So this just means that, so in this you'd have, for example, a over pi equals r squared. I just flip them around on the side, which just keeps it the same thing. And just terminology wise, I said subject of the equation. So if you're making r the subject of the equation, you have r alone, and then you have everything else on the right. And now, since it's r squared here, right, the opposite of squaring is taking the square root. So if I take the square root of both sides, that should give me r its own. So I go r square root of r squared, and then square root of a over pi. And basically, the logic I've used on so far is that if I do something to one side of the equation, I have to do it to the other side of the equation. And if I do that, it stays as true effectively. So if I divide both sides here by pi, right, the equation is still true because I've done the same thing to both sides. So it was true initially, I've done the same thing to both sides, so it's still true. So that's the logic you're using. So now going back to this, square rooting r squared is r, and then r equals square root of a over pi. And there we go, we've made it the subject of the equation. Let's move on to some other ones. So rearrange for k. So we want k to be the subject. Okay, so in this case, it's not too obvious how we can get k on its own because there's a k at the bottom and at the top. Sorry, at the top and the bottom. So in this case, kind of, when I see something like this, my first instinct is just to get rid of the denominators by multiplying everything out. So if I multiply the left-hand side by, sorry, if I multiply both sides by k plus u, so I go, let me write the equation out. So I multiply both sides by k plus u times k plus u times by k plus u. Well, I can, since I'm timesing and dividing, that goes away. So then I'm left with k is equal to a k plus u divided by b. And likewise, I can times both sides by b. So times b, and that gets rid of the b's on the right. So I'm left with kb is equal to a k plus u. And since I want to rearrange in terms of k, I need all the k's on one side, because or else if there's a k on the left and the k on the right, then I haven't really got it in terms of k. So I need all the k's on the left hand side. So I've got kb here and a k here. So kb is equal to ak plus au. Let's take the k to the left hand side. So if we minus ak from both sides, so we've got minus ak, which on the left we're left with kb minus ak. On the right we have plus here and minus here, so that cancels, which equals au. And remember, since we only want one instance of k in order to have kind of it just on the left, we factorize out the k here. K is into b minus a, which equals au. And now we just want k alone on the left, so if we divide both sides by b minus a, we should be left with k alone. So divide by b minus a, divide by b minus a. Because we're timesing and dividing, those cancel out. So we're just left with k is equal to au b minus a. And there we go. That's rearranged in terms of k. Now we need to rearrange for y. Okay, again, there's the basic principle is if we do one thing to one side, we have to do it to the other side to maintain kind of the equation and to make sure it stays true. And also, we know kind of we need to do the opposite of what is currently happening to get y on its own. So since right now we're dividing by 4 here, and this is kind of the last step in our BODMAS thing, right? When we're calculating y, we divide by 4 last, so we have to get rid of it first. Before we do anything else, we just have to get rid of this 4. So if we times both sides by 4, so we have x is 3y squared minus 5 all over 4. We times both sides by 4. Well, we'll get rid of this, right? Because again, we're dividing by 4 then timesing. So we're left with, on the left, 4x is equal to 3y squared minus 5. And now, again, in our BODMAS thing, remember BODMAS, we did this a while back. Sorry, that's a D. So we've done a division. Now we're on actually, that's not actually kind of best explained because it's a fraction. You obviously do that last, right? But here, in this case, the BODMAS is actually a bit more applicable because we have to get rid of our subtraction before we can do the y squared. So if we were, say, to take the square root of this right-hand side to get a y only, we'd have the square root of this whole thing, which isn't y alone. So we need to get y alone before we can do anything. So we can add 5 to both sides, which gives us 4x plus 5, which equals to 3y squared. And again, we have to kind of divide through by 3 because we need the y squared alone, right? If we were to say take a square root right now, we'd have the square root of 3y squared, which is kind of root 3 times by y, which is kind of not really what we want. We want the y squared on its own first, and then we can take the square root. So we divide both sides by 3. I won't do kind of this writing it out here. I think you guys get the understanding. If I just divide through both sides by 3, I'll have y squared, and on the left I'll have 4x plus 5 over 3. And I'll switch sides because you want the subject on the left. over 3, and now I can square root. And there we go. So in general, what you need to do kind of when you approach questions like this, you basically kind of just need to get rid of everything. You just need to isolate the thing you're looking for on the right. And to do this, what you're doing is kind of basically getting rid of everything as soon as you can. So equally, what you could do here as well, right? You know how I times through by 4 first? I could do, say, x is 3y squared over 4 minus 5 over 4. So I could add 5 over 4 to both sides if I wanted to, equals 3y squared by 4. And now multiply through by 4, right? And then I get the same thing as before, 4x plus 5 equals 3y squared. So there are multiple ways of doing this. It's just easier to do kind of to multiply through by 4 first, because you don't have to deal with kind of minusing a fraction, and you know you're eventually going to get rid of this 4 anyways. So you may as well kind of multiply through by 4 first. But yeah, it's kind of just a process of, as you do more questions, you'll recognize which kind of thing you need to do first. But in general, like it just with fractions, if you have a fraction, just get rid of that first, and then work through the kind of, so you go first. You'll do is kind of fraction, or kind of addition, multiplication, and then you'll move on to addition, multiplication, and then it will be powers. Kind of in general, in questions such as these, which are kind of the most likely the ones you come across. In questions like, for example, if you had something like x is equal to 5y plus 7 all squared, well, you'd have to get rid of the square sign first, right, before you can kind of deal with the 5y plus 7. But it's less likely you'll come across something like this. But if you do, obviously, kind of get rid of the power first, so you get root x is equal to 5y plus 7. Get rid of the 7 now, so 5y is root x minus 7, and then divide through by 5. And it's just that process, basically. Just, you know, little by little by little, isolating the term you want and kind of rearranging in that sense. Make sure you kind of practice these. I know I would get stuck a lot on these, especially questions like this one here, where there's 2 instances of it, when it's on the top and the bottom. That really confused me. What you need to remember is this step here. This is the big step, the factorization step, where you kind of say, oh, so there's 2 of these, let me factorize out the k, and then you get the b minus a. So that's a key step here, but make sure you practice some of the harder questions like this, and hopefully, yeah, it all made sense. But yeah, see you guys in the next video then.